Solutions, Part 3. Let's consider this example. Consider the addition of 100 grams of solid to 100 grams of water. Now the solubility of this solid is 91 grams in 100 grams of water at 25 degrees, and like all solids, its solubility goes up to 110 grams in 100 grams of water at 50 degrees. Let's look at the first beaker. The first beaker represents the time when the solid is still continuing to dissolve. When I add 100 grams of solid to the 100 grams of water, the 100 grams of solid does not dissolve all at once. It's still dissolving. At this point, we have a condition in which 95 grams of the solid is still at the bottom and only 5 grams have been dissolved. This is an unsaturated solution. Even though I have 100 grams of solid in the beaker, only 5 grams have been dissolved. 5 grams is less than the solubility of this solid. The solid will continue to dissolve until we get to beaker 2. Beaker 2 represents a saturated solution. At this point, 91 grams of the solid has dissolved. Remember, the solubility is 91 grams. All 91 grams have been dissolved at this point. Now, since we added 100 grams of the solid, 9 grams remains undissolved at the bottom of the beaker. This condition is known as dynamic equilibrium. In a saturated solution, the dissolved solute is in equilibrium with the undissolved solute. So the solid at the bottom is dissolving, and at the same time and at the same rate, the dissolved solute is recrystallizing. Now, if we heat up this beaker and its solubility goes up to 110 grams, all 100 grams of solid will dissolve in the water. At this point, we have an unsaturated solution. We have less than the maximum amount dissolved. Remember, the solubility at 50 degrees is 110 grams. Since I only have 100 grams of the solute dissolved, this is an unsaturated solution. This represents our third beaker again. 50 degrees, all 100 grams have been dissolved, an unsaturated solution. Now, if we cool this beaker very slowly with its contents, all 100 grams of solute that's dissolved will remain in solution. Even if we bring it down to 25 degrees, if we're careful, all 100 grams will remain in solution. This is referred to as a supersaturated solution. More than the maximum amount is dissolved at the particular temperature. Remember, at 25 degrees, the solubility is 91 grams in 100 grams of water. Right now, that excess 9 grams has dissolved in the water. This is a supersaturated solution. Now, if I come in and I add a little bit more of the solute, or I stir it, or I do anything to disturb the solution, a precipitate is going to form, and I'll wind up with the last beaker, and it returns to a saturated state with 9 grams on the bottom, 91 grams dissolved. So when we consider this process again, we start with an unsaturated solution with more solute still dissolving. We eventually reach the saturation point where the maximum amount of solute is dissolved at the given temperature. Any excess solute stays at the bottom in dynamic equilibrium with its dissolved solute. Now, If I heat it up to 50 degrees and the solubility has increased, all 100 grams will dissolve. And it's going to be an unsaturated solution because at this temperature, the solubility is 110 grams in 100 grams of water. Now, if I cool this solution back down to 25 degrees, all 100 grams should remain in solution. This is a supersaturated solution. But remember, supersaturated solutions are very unstable, and anything can cause precipitation of that excess solute to occur. At this point, we're going to look and see what happens when we add more solute to 3 different solutions. If I add more solute to an unsaturated solution, it's going to dissolve. If I add more solute to a saturated solution, no more solute dissolves, and the excess, the additional solute that I add will just go to the bottom of the container. Now, if I add more solute to a supersaturated solution, all of the excess solute that was dissolved in that supersaturated solution, in addition to the solute that I just added to the test tube, is going to fall to the bottom of the test tube. Let's consider the solubility of liquids in liquids. Why is it that oil and water don't mix? Well, first of all, we need to know some definitions. Liquids that are soluble in one another are miscible. Miscible liquids would be water and alcohol, water and orange juice. Liquids that are not soluble or liquids that are insoluble in one another are called immiscible. Oil and water are immiscible. They do not dissolve in one another. The reason why liquids do not dissolve in one another has to do with molecular bonding and molecular polarity. Likes dissolve likes. What this means is that polar liquids dissolve in other polar liquids, and nonpolar liquids dissolve in other nonpolar liquids. Polar liquids do not dissolve in nonpolar liquids. This is why oil and water do not mix. Water is a polar solvent with a positive end on the hydrogen and negative ends on each oxygen. Water is a polar molecule. It is a polar solvent. Oil, on the other hand, is nonpolar. This is why oil and water do not mix. The last thing you need to know for this unit on solutions is concentration. Concentration is defined as the relative amount of solute in a solution. The 5 formulas you need to know are percent by mass, percent by volume, parts per million or ppm, molarity, and molality. You should be able to determine these concentrations for any solution. I have included the YouTube videos that you can watch in case you forget how to calculate molarity and molality, percent by mass, percent by volume, or ppms.